Good evening, everyone. I'm Chris Wojnicki. I'm the president of the Fort Worth Astronomical Society, and this is an impromptu, rapid star party that we're going to have. The night is clear. It's kind of cold, so it's a bit chillier than it was a couple days ago. We'll see how well this goes. We had some technical difficulties, so we're starting a couple minutes late, but that's okay. Here's the setup that we have right now. If I can get my... Oh boy, where'd I put it? I did have my flashlight. Okay, so we got a slight delay. I'm actually going to mute the the Zoom meeting just slightly, so it's a bit quieter. I hope you guys can hear me well. Get the microphone a little bit closer to myself. Okay, here we go. We have two telescopes out here. We have a Teleview 101, and we have a 8-inch Ritchie Cretan astrograph. So what we're going to be doing today is we're going to be hopefully, I think, looking at the moon. I think we're going to be able to go to, we will be able to see Venus, and hopefully, I hope, we will be able to try to catch the comet again. The moon is, from my point of view, it is behind my house's roof. I'm not sure how this is going to work, but we'll see. So I am missing one connection, but here we go. We're going to go frame and focus. No, we're going to go planetary. So I'm going to switch over to view from software. Here we go. So what we're looking at right now is the moon. This is a not great image. So here's what I'm going to do. We're going to switch to planetary, and we're going to see if we can't get it a lot faster. So the problem with the moon is that it is very, very bright, and we don't necessarily want that. What we want instead is a view like this. So let's go ahead and take, there we go. So there is that weird delay between what YouTube has and what Zoom has. Not really sure how to fix that. I think what's going on right now is somebody has their audio turned up, so if you can go ahead and turn your audio down or mute it, I won't have a feedback coming back through Zoom. That way I can hear y'all talk, but it's kind of weird the way I have a delayed echo. Okay, so here's what we're doing right now. I have the moon through the astrograph, through the 8-inch. The reason why it looks red, this is a modified camera. If you look at a regular camera's sensor, what you'll actually see is this little cover on it, and that cover blocks infrared light. Not all of it, but quite a bit of it. CCDs and CMOS chips are very sensitive to infrared light. As astronomers, we want that. As normal photographers, we don't want that. Well, this camera has the infrared sensor taken off completely. The advantage of that is that now we can go ahead and image stuff like, oh, I haven't actually done it. Hold on. We can image things like nebula much, much better. So here's what we're looking at. We're looking at the picture of the moon, and we're using backyard EOS. I'm doing planetary. I slowed it down. Let's zoom in. Here we go. Oh. So we're looking at the terminator right along here. The terminator is the line between daylight and night. I can make it a little bit faster. Go a little bit faster, make it a tad bit brighter, bring out some contrast. There we go. So we're able to see some craters along here. We're able to see mare. What mare is Latin for seas. So the mare, the darker areas on the moon, these are places where the magma. All right, let's go back. Big stuff hit the moon. Small stuff hit the moon. The big stuff that hit the moon punched all the way through the crust, went into the mantle. The mantle material then welled up and formed the mare. Mare is mostly basaltic material. It's the same stuff that we have on the bottom of our oceans. It is a dark rock. We call it mafic. That's why the mare appear dark. The lighter stuff is silicates. That's closer to our crustal material. So the silicates are much lighter. They float on top of the mantle. Much lighter color. Very little iron in there whatsoever. So what you're looking at, these mare, is places where large asteroids punched holes through the moon's crust, and then the magma from the mantle welled up in its place and eventually cooled down and solidified. The craters are where smaller objects hit the moon, so they did not punch all the way down through the mantle. At least the younger ones didn't. The mantle right now is pretty cold. I think the core is still hot. I don't remember if it's molten or not. I don't think it is because Moon does not have much of magnetic field, if any. So let's zoom out again. Zoom. Oh, not 5x. Let's just zoom out. So let's pick another position along here. Whoops. Double click to lock in. Go 5x. All right. So again, we're looking along the terminator. We see some more craters. We actually see crater within a larger crater. Anyone? I'm checking very quickly to see if anyone's got any questions. No. Okay, here we go. No questions. If you have any questions, go ahead and ask. Let me turn up the audio from Zoom as well. Are you guys seeing this well on Zoom? No, you can't see this on Zoom because I'm not doing a share. Let me see if I can. We're actually doing some tests today, so bear with us. I want to see if I can share one screen in Zoom. Okay. I think you guys can see this in Zoom. I wish there was a way that I can go ahead and move this part off. I can, yes. All right, cool. Move that off to a different screen. Makes it easier for me, makes it prettier. Okay. Hope you guys are seeing this going out. All right, where were we? Okay, a couple things. The moon looks kind of wiggly right now because it's getting lower in the sky. I am shooting this over my house. My roof is warmer than the air, so we have air currents coming off of the roof, and it's causing the moon to be kind of a bit wiggly, like looking through water. It is basically an optical illusion. It's the same thing as if you're on the highway in the summer looking out and you think you see water. It's just air moving. I'm not doing anything special with this right now. We're just taking a look. Does anyone have any questions? Any comments? Zoom out. Oh yeah, 5x. I haven't used this part in a while. So for anyone wondering, the reason why it's red, this is a modified camera. And let's see if we can... How much can we zoom in on this thing? I don't think we can, just because this is the planetary mode. We can see some more. Now, I think you should be able to see this on YouTube. You should be able to see this on Zoom. If you look right in the center here, there is a small mountain coming out of that crater. It's really hard to tell, but every once in a while it comes through. So this is called a rebound mountain. If a large enough asteroid hits an object, whether it's the moon, whether it's the Earth, whether it's Mars, what happens is it knocks in the crust, it melts the material. If it's too small, it just gouges out a crater, just blows out. If it's big enough, it will melt the material underneath and it will push it out. When it pushes it out, it's a lot like a water droplet falling down on in a glass of water. So the water will go out and then it'll come back and form a little peak and a little droplet on top, and then it'll fall back down. Well, this is molten rock we're talking about. So instead, we have that rebound, but then it freezes. And we call that a rebound mountain. So the rock cools down because it's not quite as fast as water. It's quite large. It'll come back together again, form that mountain, and then just kind of freeze. So the larger craters, we typically see rebound mountains in the center. What's really interesting is especially on the moon, in some of the larger craters, if you're down on the crater bottom, you may not know that you're in a crater. The walls of the crater are so far away that they're below the horizon. So it's only if you take a rocket up from the middle of the crater that you can see the walls coming up over your horizon, and then you realize that you're in a crater. Otherwise, it looks like a flat plain with probably some smaller craters around you and lots of rocks. If you're a geologist, you can probably find broken rock, shock fractures, things like that. But once you move towards the walls from the center, then the walls come up again. Okay, any questions? No. All right, so Patrick is asking about the comet. So we have not gotten to the comet. All we're looking at is the moon so far. If you have any questions, now's the time to ask. Specifically, I don't remember what these are. We can find out. And there's a handy dandy way of finding out. And we bring up Starry Night Pro. So I finally figured out some of the issues that we were having on Wednesday. On Wednesday, I had issues connecting to telescope control. I don't have those issues today. So what we're looking at here is, there we go. Let's see, surface model. So we're looking at, we can do all sorts of stuff with this. But what I wanted to see is, what is this place called? I don't think I have it on here. Large moon size. There is something on here that allows me to do... Oh, it's on my new version. Oh, well, that sucks. I haven't been able to do that. So where is markers, outliers? Show info. So I can't select the moon. Let me do it. Zoom back out. So moon is selected. On my new version, there is actually a way that I can see what I'm pointed at, but this one does not have it. Oh well, looks like I need to install the new one. There's also a way to do labels, planets, moons. Let's see if this one will do. No. This is an older version. My newer version actually has a lot more details on here than this one does, but oh well. So we're dealing with craters, we're dealing with mare. I guess I could always pull up my phone. If anyone wants to talk, if anyone says anything about what's going on, that'd be great. Oh look, I've got to go to the waiting room for Zoom, and I gotta let people in. Admit all. Okay, cool. Hello, there's Jim. All right. What's really interesting is if you look at this, the moon is moving, and it's moving because the Earth is moving. So this application actually lets me keep track of what's going on, and I've got what do I have on here? Whatever I'm magnifying the image by, I'm magnifying the rotation of the Earth at that same speed. So if I magnify 100 times, then the apparent rotational speed of the map is 100 times as well. So let's go back to Backyardios and see if anything's changed. No, we're pretty much looking at the same thing. So we have the limbs out here. Let's see. Anything? No. Anything interesting there? Let's find out. Don't see a whole lot of interesting things. We see a little rebound mountain there. Again, we have airplanes and helicopters going overhead, and the reason is I am on a one of the patterns for Spinks Airport down here in Burleson. So all day long and probably to about 11 o'clock at night, typically have airplanes flying overhead trying to land, or after they've taken off, looping around and practicing sometimes. Any questions? Let me see. No. Okay. John is asking, am I using a Canon? I am actually using a not a Canon 60 modified. This is a Canon T3i that's been modified. So this is an 18 megapixel. This one has pretty low noise for what it is. So it's a good camera. Okay, what are we going to do now? We have Venus. I could actually see Venus pretty well. Let's see if this works. So we're going to slew over from the moon, unless anyone has any other moon questions. No, I don't see any more questions. Okay, Patrick thinks he's got a shot of the comet. All right, cool. So we've got the moon. We have Pleiades. Oh, well, let's see if we can find Pleiades real fast. So slew to this location. I really hope this works. Crossed fingers. Okay, it's going up and it's going down. What we should be able to see when we go to here, let's go to a longer exposure. There we go. No, kill that. Kill that. So there we go. We have the Seven Sisters. We have the Pleiades. All right. Longer exposure. A little bit more and get some more shots, a little more stars out of there. So remember, this is video. This is live video, so it's not. We're not going to have a lot of nebulosity, but this is the Seven Sisters. Well, at least some of them. We can do a quick image, so I'm going to just go to imaging, and this is a very long focal length, but we're going to do duration. Let's just do a 10-second exposure, 1600. Let's do 800. Let's do with less noise and 15 seconds. So what I'm doing right now is I'm going to take one image, and all it's going to do is a 15-second exposure. And just like last time, I have this set to do a dark frame reduction automatically within camera. What that means is I take the light frame for 15 seconds, then the camera will shut the shutter, and it'll take another picture, which will be a dark frame. The dark frame is the heat noise around it. It's the noise from the camera itself. It's infrared radiation from all around. So it takes that second image, subtracts it from the first, and hopefully it deletes some of the noise. We'll see how it goes. So, checking here. All right, nothing on the chat. All right, so we've taken the image, taken the dark frame, waiting on the download. There we go. Now we have the Seven Sisters. We see 1, 2, 3, 4, 5, and I don't think we're capturing everything, but what we are doing is seeing some of the deeper stuff. Not terribly deep, but the stars are fairly round. Looks like we're in pretty good focus. Yeah, that's pretty good focus. That's not bad. Let's do this. Let's take a 30-second exposure. Now, I have a guide scope hooked up. I forgot to focus it. So I can bring up PhD 2, and we can go ahead and train it. But had some camera issues right before we started. I didn't have time to get a focus or get PhD to work. So we can do that later when we're dealing with the comet. We want to do a little bit of tracking then. PhD also has a feature where you can track comets. For anyone on here that doesn't know what PhD is, it stands for Push Here Dummy. What it actually does, it's a system for controlling a telescope to keep it locked on a star. What you do is you have a separate telescope, a separate camera. It takes a picture every 1 second or 2 seconds or 3 seconds, whatever time you want. Then you lock it onto a star. Once you've locked it onto a star, you train it, and the system moves it a bit left, moves it a little bit to the right, moves it up, moves it down, and then it knows how much it has to move it. So once you lock onto a star, it stays locked, and that keeps the stars from streaking. It keeps the stars from being oblong, hopefully. Here we go. So let's see what this looks like. Okay, now we're a bit deeper. We can see a lot more stars. So let's go to the first one, load it. You can see what it looks like. So we're not capturing as many stars. We go to the second one, we see some more. We see a lot more in here, we see more through here, and these are coming out a lot brighter. So just for kicks and grins, I'm going to go ahead and do a 60-second exposure. I don't expect to see a lot of nebulosity. We are in the city. I only have one filter on there. I didn't double stack it like last time. I guess I can always get one. But one of my cameras died. I have two modified Canon T3Is. One is modified a little bit more, one is modified a little bit less. This one is the one that's the full mod. It's a naked sensor. There's no filters on it whatsoever. The other one is a partial mod. There's one of the two filters still on there. But that second one died, and it died this afternoon. I tried to get to connected. I had issues. I don't know what's going on, but it's beeping at me, which is never a good sign. So I had to pull out my unmodified Canon T6i. So that's on the other scope. That's on the refractor. We'll see how that one goes. All right, so we have a exposure is done. We're going to do the noise reduction, another 60 seconds, and we'll see what the Pleiades looks like. Oh, Mike, you can't really do more than 3 seconds before trailing. Yeah, do you have a Dob? If you have a Dob, then yeah, there's not really any tracking. The Orion 8-inch Dob with the go-to feature, I had one of those and I tested it out. We did have some issues with it. It could track, I think, for photographic purposes. You could do live stacking images for about 5 seconds, and then it jumped. So there's like a little error there in the motion. We couldn't get it to really do any more than that. So planetary stuff was fine, but anything like this, it just didn't work. So I am, this mount, it's a German equatorial. It is a Celestron CGEM DX. I have a really good polar line on there. There is no guiding whatsoever right now. And let's take a look at those stars. Let's see if they're round. They're not bad. They're not bad. For 1 minute exposure, that's not too bad at all. So what are we seeing? We're seeing a lot deeper now. Ignore this black spot. That's actually a piece of dust on my sensor. I haven't bothered to clean it off yet. It's kind of a pain, and you don't want to clean your sensors too much. But by using some techniques, we can go ahead and get rid of that dot in the final processing. But in the meantime, it doesn't really bother me. So this is part of the Seven Sisters. And I'm actually going to see if I can get this to work. Connect. This is a second one. I'm hoping. Doesn't want to connect. I'm trying to get this to connect to my T6i. I don't think it's going to let me connect. Just out of curiosity, I want to test it, see what it's going to do. I don't see it. Oh, I don't see anything on here. Well, yeah. Oh, that sucks. All right. So I guess we're only going to be able to work with one camera today. Oh, well. It is what it is. It's really too bad. I was hoping to do some more stuff. But as we have the Seven Sisters here. Anyone have any other questions? Actually, Sean says that the Pleiades is the inspiration of the Subaru logo. Actually, the little asterism, the group of stars is called Subaru in Japanese. So that's why the constellation is the logo for Subaru, the car company. What else? Okay, let's go on to Venus. So back to here. You can see we're still on. I'm just going to zoom in very quickly. So what we're seeing is 1, 2, 3, 4. Is that what we're seeing? Let's just go back. 1, 2, 3, 4. So we're not seeing the whole thing. The reason why we're not seeing the whole thing is because I have a very limited field of view with this telescope. This is an astrograph. It's an 8-inch f9, so it's a fairly long focal length. It is meant for high power observation. It's not really meant for wide field stuff. When we're looking at the moon took up pretty much the entire field of view. So where's Venus? Oh, there we go. There's Venus. I can see Venus right above. Yeah, I'm looking up at it right now. I'm going to select it, and we're going to slew to Venus. So once everything is connected, it's quite nice. So what are we going to see when we see Venus? We should see it pretty much as it was on Wednesday. A crescent, or not crescent, a half Venus. So this is what it looks like. Let's do center. So this is what it looks like within the application. Let's see what it looks like from the camera. To do that, we're going to go to planetary mode, because I want to basically video of it. There we go. Does not look the same, does it? Well, there's a reason for that. We have the setting on bulb. We have to make this go much faster. Venus is pretty bright. That's how bright it is. So we got to go way, way down. I'm going to cut it down even more. It's pretty low in the sky. There's a lot of crud. So it's not twinkling much here, but it's big and it's bright, and we have some air movement here. We're not going to get too much better of an image right now. But on Wednesday, we could actually see a little bit of dark cloud detail right in this area here. We're just not seeing that today, unfortunately. I'm going to see if I can do this. Let's see, what does this look like? There we go. That's a little bit better. Yeah, but again, we're just not seeing a whole lot of detail. You can see that this is not a complete disk. This is a half disk, just like it is on here. Except, if you look, this telescope actually reverses the image left-right. There are some telescopes that reverse it up-down, and others that reverse it up-down and left-right. This one just does it left-right. So that is Venus. I get out of here. There we go. That's how we get out of there. Any questions? Kurt's saying that he's got about 60 oak trees and he can't see enough of the sky to make it worth it. I'm actually fortunate in the new house here. It's pretty open, except for where my house is to the west. To the south, it's pretty open. To the north, it's relatively open, but that's back towards downtown and a lot of light pollution. And then it's open to the west, but so are my neighbors' windows. And so far, no one's complained that I'm looking in their windows with telescopes. I don't. These telescopes aren't made for stuff like that anyway. But it's a nice open sky, and the only issue I have is the airplanes flying overhead. And in November, I was out here doing a test run and broadcasting. One of my neighbors was curious, so he sent his drone over to see what I was doing, which was interesting. Okay. Oh, Kim, you let your daughter stay. Hi, Pearl. Better than Mickey Mouse? I have a 4-year-old son. He is up in bed. This is past his bedtime. We put him down at 8 o'clock, and he tends to stay down. But he did help me set up earlier today, and he will be watching this later on. Okay, so we've seen Venus. Any questions about Venus? Any questions in general? Questions about the equipment? Questions about the setup? Just go ahead and chat them in, and I'll pick them up as I go through. So Venus is still 3 hand widths up, so it should be roughly 3 hours before Venus sets. I don't see the moon from my particular angle. That's just because my house is right here. But I've got a nice little setup here. I've got my table. I've got all my equipment. I've got a little studio light so you can see me. Otherwise, it'd be that. It's kind of dark. All right, so that's back up. Oh, I've got someone here in the waiting room. Let's let him in. See if that works. Hello, Mark. You're now in the waiting room. All right, hopefully everyone can hear me. It looks like the audio is going out. Let's see. Okay, Curtis, what scope am I using? This is a 8-inch Ritchie Cretan carbon fiber. This is so it's 8-inch f9. It is an astrograph. It is not really a visual telescope, though you can use it as a visual telescope. It's designed specifically for taking photos. So we've seen the moon, we've seen Venus. I am going to now see what we can do about... Oh, there we go, come on. I don't think that we're terribly accurate, but here's what I'm going to do. I'm going to go north. There's Polaris right there. Here is Doobie. That's how you pronounce it. And what I want is C2019Y4. Help if I could do number lock. 2019. Oh, come on. We're just looking at it. I think it's the slash. It's the wrong slash. No. How about Atlas? Atlas, so we're looking at Atlas Y4. Y4. Seriously? It is Y4, right? That's what we were looking at last time. Here it is, Y4. Okay. I don't even know why it didn't show up. There it is. Y4. That's what we're going to slew to. And I'm going to slew to there. So this is the comet that showed up in December, and it wasn't terribly bright. But I think somebody found it with an 8-inch scope at that time. No, sorry, this is the Atlas. I was thinking of a different comet. Atlas is a automated asteroid tracking survey. What that means is they have a bunch of telescopes with cameras, and they will take a picture of one part of the sky, and then move on, take another part of the sky, take another part of the sky, take another part of the sky, and then they come back the next day, and they do the same section, and the same section, and the same section, the same section. And then computers will go ahead and compare the images. Any little dots that change position are probably asteroids. So that sends off an alert. That particular part of the sky gets checked again, and once you have 3 positions of an object, you can calculate the conic section, which in the case of an asteroid is almost always an ellipse. Once you know what the orbit is, what that ellipse is, then you can see, is this a near-Earth crossing asteroid? Is this a asteroid out in the asteroid belt? Is it a Trojan or is it a Greek? The ones that are in front of and behind Jupiter, and at the Lagrange points. We want to know what the near-Earth crossing asteroids are, because one of them eventually is going to hit us. So we need to know well ahead of time so we can stop it. So the survey doesn't just pick up asteroids, it picks up comets as well. So you can see in the search here, these are just some of the comets that Atlas has picked up. If you see Atlas Centaur down here, Atlas Centaur is the upper stage of a rocket. It's a very tried and tested rocket back from the 60s, but typically the upper stages stay up in orbit unless they have enough fuel to specifically do a re-entry burn. A lot of times they don't. They're just kind of left up there as space junk. So it orbits around and around and around and around, and usually if it's high enough, it doesn't come down. If it's low enough, then it'll go ahead and eventually burn up. All right, let's go to Backyardios. We're not seeing anything. Nothing at all. I didn't expect to, because we're doing planetary. So even if I have this set here, I'm not seeing anything, and we won't. We need a much longer exposure. So here's what I'm going to do. We're going to see what we can pick up on we need to do a test exposure. So I'm going to do 15-second 1600 ISO and kick that off. Okay. Oh. Hello, dear. My wife is watching now, and she's on the chat. So we're taking a 15-second exposure to see if we can find the comet. And again, it's 15-second exposure followed by 15-second dark frame noise reduction exposure. And wait for the camera to go ahead and process that. If we were actually out in the field taking photos, we would not be doing this. I'd go ahead and set it up so that the noise reduction is turned off. Take a bunch of dark frames at the beginning of the night, a couple more at the end of the night, and blend those together so we can spend as much time as possible doing actual lights. I don't know about you, but I see a comet. That's a comet right there. See that little fuzzy thing? That little fuzzy thing is the comet. It's small. It's tiny, because we only did a 15-second exposure. So let's see if we can pull it out a little bit better. I'm going to do a 40-second exposure, still at 1600. There will be a lot of noise to this. That's okay. I'm not really concerned. But that little fuzzy is a comet. Now, if you actually have a decent-sized telescope, if you have like an 8-inch Dob or something, and you look at it right now, you can actually see pretty well. If we go back to the map, so there's Comet Atlas. Here is Polaris, and I'm going to turn on some labels. Okay, let's do stars. There we go. So here's Doobie, here is Polaris, and when we were looking at it Wednesday, the comet was actually over here. So, or no, it was down here. Sorry, it's down here. Here, it was to the right of a line straight up with Polaris. I want to say it was over here. I think this is where we picked it up because I recognize these stars. In just a couple of days, it's moved over that much. And actually, if we stay up a little bit, couple of hours observing it, we will see it change position from image to image to image. Not very much, but it's enough. And the issue is, let's say we want to do like a long exposure. We want to really see the tail. We want to see the whole comma all around it. And we do, let's say, a 3-minute exposure. In that 3-minute exposure, the stars may stay in position. We can lock onto the star. Problem is, the comet's going to move, and it will smear the comet. So PhD actually has a feature that I can go in and track on a comet. I have never done that before. Hey, how about that? I see a little nucleus and I see a little bit of a tail. This is better. There we go. Play with the histogram just a tad bit. So we have a little streak. I'm going to see if I can zoom in even more. Let's see, is that 26%? Let's go back up 100%. Can I zoom in more? Yeah, there we go. So we can see a little bit of a head there, and there is definitely a tail. And the reason why the tail is going up this way is because it is the telescope is flipping the image right to left, left to right. whatever. So in actuality, the tail, if I just had the DSLR and I was just pointing it directly at that with a long lens and took a picture, regular telephoto lens, the tail would be going out in this direction because the tail is always pointing away from the sun. It doesn't matter which direction the comet is going, the tail points away from the sun. So, let's see. Mike, I actually have that that 114 millimeter. I have that in the Meade. That was my very, very first telescope, and it was small, so I built a 10-inch Dob out of my next one. So I'm going to do this. Let's get a longer exposure. Let's do 60 seconds, but I'm going to cut down to 800. You know what? Let's do 80 seconds. So what I'm doing now is I'm cutting down my ISO. That reduces my noise, but I'm making a longer exposure, so I'm trying to get more data. I want to see just what that little thing is doing, but that is actually the comet. I'm going to go ahead and reset the histogram so you can see it. There is definite streaking. It's not a whole lot, but at 1600 ISO, it's pretty noisy. So thank you, Sean. I think this is pretty neat too. We could do more, but again, we're kind of under lockdown with COVID-19. So I'm looking at some options. I have a place down in Grandview I may be able to go to and still stay isolated down there. But right now, I'm just staying in the backyard. We're not going anywhere. We haven't really gone anywhere. In fact, today I think is the first time in a week and a half I actually left the house and went down the street, and then came right back. And that we've just been stuck at home. Except now, going out to the backyard, and it's kind of nice. It's quiet. I don't hear traffic noise very much. Yeah, it's pretty quiet. I like quiet nights. All right, so we got another 75 seconds of noise reduction. Anything like... Okay. Oh, Mike, I know that feeling. I had that, my little 4.5-inch, when was that? That was 20 years ago. Yeah, more than 20 years ago, and I made that telescope do things it was never intended to do. I tried doing astrophotography with it. Oh, I had a little tracker. I had a what was it? A off-axis guider. It wasn't pretty, and it didn't do the job very well. But from that, I graduated to Dobbs, and from the Dobbs, I graduated to that stuff. So while it's doing the noise reduction, I'll do a quick tour again. You can see the telescopes. Okay, maybe you can't. You can see one of them. So this is a TeleVue 101 apochromatic refractor. This is a 4-inch f5.4. Unfortunately, the camera that I have hooked up to, it doesn't seem to be working. The camera I'm actually doing, or sorry, the telescope I'm doing imaging with is an 8-inch Ritchie Cretan carbon fiber. It's doing a pretty decent job. What I could actually do is toss on my Comet filter, but I don't think I'm going to. Oh, there we go. Okay, so we have a little bit of elongation. So I'm going to zoom out. So the stars aren't round anymore. So I'm kind of in a weird position in the sky. Places right around the North Pole, North Celestial Pole, they're kind of hard to guide. Little errors, they're just weird errors. So the stars aren't exactly round anymore, but you can see a whole lot where this is just a little bit lighter than the area around it. At least I can. I'm going to see if I can get in here again. Yeah, if I move it around, it's a little bit more obvious that there's a coma around about that big-ish, at least what I'm picking up. And then you can see there is definitely a tail going out. So we did manage to pick up the comet. So again, this is Comet ATLAS C 2019 Y4. And I keep glancing over to another screen. I actually have monitor over here, and oh, Patrick needs into the Zoom. Oops, needs into Zoom. There we go. So, do I see Patrick? I see a black screen for Patrick. Are you there, Patrick? Anyone? Anyone at all? No? All right. I'm gonna look through here. So, any other questions? Oh, hello, Christina. Yeah, we're all kind of new to this in terms of broadcasting, but this is stuff that we've been doing for a while. We have a lot of astrophotographers in the club. There are people who've been doing this for 20 years or more. There are people who've been doing this back when it was film photography. I never got to hyper film, but I knew how to do it. It was just really expensive, and I didn't want to do it. So kind of a pain. Instead, now, today, we have a lot of different options. We have the ability to do stuff with DSLRs, modified and unmodified DSLRs. They're dedicated astronomical cameras. As an example, I have a ASI 120 color. So this is a... Back to focus. Come on. There we go. It's kind of hard to see, but there we go. So this is a little, there we go, ZWO camera. This is a little dedicated astronomical camera. It's got a little bitty chip on there, but they're made to be very sensitive to light, so they're not filtered quite like a DSLR would be. We have some options that we can do. We can actually do really long exposures now that we couldn't do before. Let's start with PhD guiding to, let's see what PhD does. So PhD is a really? Oh, fine. Yeah, I can't click on it 10 times. Who would have thunk it? So PhD stands for Push Here Dummy. It is a guiding application that we use because it is really, really simple. What it does is allows me to go in and... Oh, let's see. Let's remember how to do it. There we go. Connect. So pick up a camera. I'm going to connect the camera on mount. Not going to touch that. And close. So what I'm going to do now is... How about you? I got nothing. Why do I have nothing? I don't know. Why do I have nothing? I have no image. I think I know why. Because I wasn't paying attention. And now I need to go back there and find out why I don't have anything going on. I will take this off to another screen. There we go. So I can deal with that one thing at a time. All right, on here we have another 10 seconds. So we're going to do 10 seconds of exposure, 5 more seconds, and then we will do another 2 minutes, and that 2 minutes will be the noise reduction, the dark frame, so we want to get a better image out of it. But at least now we actually have a comet. We actually have a tail for the comet, which is pretty good. So Mike, you're looking at a VX mount. CloudyNights.com. I highly recommend CloudyNights.com. There is a free classified section on there. People selling their used equipment all the time. I bought most of my stuff used. I bought pretty much all of my stuff used. New stuff is very expensive. Sometimes you just can't find anything used, and you have to get it new. Our advantage here in Dallas Fort Worth is we have Astronomics up in Norman, Oklahoma. It is very close by, and typically anything they ship is either here the next day or the day after. So we can usually get stuff pretty fast. They are very, very good. They are actually the owners of Cloudy Nights. So I also recommend supporting them. But Cloudy Nights is a good way to get equipment if you don't have the budget to buy new. You can always buy it used. So while this thing is going to the 45 seconds, I am going to go over to the scope and I'm going to see if I can figure out what I'm doing wrong. Okay, I don't know what my problem is, but I'm going to swap it out for a totally, oops. Yeah, I'm going to swap it out for a different camera. So when in doubt, fix it. Oh wait, but first, let's see what this is going to be like. All right. Ooh. Hey, we got decent sized stars too. The stars are relatively round, and we definitely have a tail. So I'm going to play with this a bit. Let's see if we can play a bit with the histogram. Now, I don't have Photoshop on here. I've got it on my workstation in my office. I could do a whole lot more with it there, but nah, boost that. There we go. All right. So I want to be able to boost this. So we're going to do this. Yeah, we're going to do that. Yeah. It's not quite what I wanted. Yeah, I'm not really certain how this histogram is supposed to work. This is not the way my histograms typically work. But yeah, I'm just playing with it. Okay, here we go. This is not half bad. So again, it's ISO of 800. We have a lot less noise than we had at 1600, but it's pretty good. So you're welcome, Mike. Go ahead and check out Cloudy Nights. Okay, take a look at this. I want you to see what's going on. I'm going to zoom out because I think zooming out is going to give us a bit better of a view about what's going on. Okay, so I think what we're seeing is vignetting here around the edges, brighter spot in the middle, but there is a bright area right around there. So we are picking up that comma, and we are picking up part of the tail. It's not a lot, we are picking it up. So here's what I'm going to do. I'm going to go ahead and do, what time is it first? 9:55. I'm going to do 4 exposures. We're going to do 2-minute exposure. Ooh, yeah, let's do that. We're going to do 2-minute exposures. We're going to leave it at ISO 800. And I'm going to do a mirror lock so I don't get any jump on there. I'm not going to do a pause. We're going to let that go. So this lets me do a lot of fine control with just how I want to do it. My temperature is down to 28 degrees. That's good. It was up to 50 earlier. The lower the temperature, the better the noise. I have something that I could put on the camera to cool down even more. It's not necessary right now. We're doing this for fun. We're not doing anything really special, but we are picking up images. So here's what I'm going to do. We're going to take 4 images. So this is going to take us 8 minutes plus 8 minutes, 16 minutes to get everything done. But we're going to be able to see images in the meantime. We're just not going to be able to slew off to a different object. But what I want to see is over the course of 18 minutes, really 16 minutes, how much this comet moves. And we should see it moving down and to the right on this image. Right, left, camera's reversed. It is what it is. So I'm going to reset this. Let's see what this does. 3, luminosity, RGB. There we go. So I'm looking at luminosity. Yeah, I don't want necessarily color right now. I want to see what this looks like. And I really want my camera, my second camera, to work because I can put a Comet filter on that thing. See if I can see it a bit better. But yeah, we are getting a tail. We're getting a little bit of Comet around there. Okay, that's not bad. Anyone have any questions about comets? Comets they're basically dirty snowballs. That's the way they've been described for a while. Think of it as a chunk of ice and dirt, but not like a snowball in that it's white, but a snowball covered in carbon. It's dark. Its albedo is fairly low. We don't see them when they're further out in the solar system. We only see them once they cross over the, what's it called? I think it's called the waterline. It's the point where the temperature goes up above the melting point of water. In the what is it? The Goldilocks zone, I guess you can call it. So when it gets close enough to the sun that the ice starts to sublimate, to melt and sublimate, it starts going off as water vapor. We want to see that, and there's enough energy in the sunlight that actually disassociates the oxygen from the hydrogen in the water, so we can actually see oxygen in the gas. That's one of the things that we look for. The Comet filter that I have looks for excited oxygen, oxygen 3, the third energy level, and it also looks at carbon. So there are 2 lines of carbon it looks at. For people who don't understand what a filter does, light is broadband. It is a broad spectrum. A white light has light of all frequencies. However, some elements, when they're excited, give off light in only very, very narrow frequencies. For example, with hydrogen, the first energy level, it gives off a very, very deep red light. We call it hydrogen alpha light. One reason why we modify our cameras is to allow more of that light to hit the sensor, to not be blocked by a filter. Oxygen gives off a greenish blue light at the third energy level, oxygen 3. Sulfur gives off a red color similar to, but a little bit different from hydrogen, at sulfur 2. And the oxygen, sulfur 2, and hydrogen alpha, we have specific filters for those. Those filters are used on Hubble, and then they false color it. So the hydrogen is still red, but they shift the sulfur over to green. So instead of it being a red color, they shift it to green, and they shift the green-blue of oxygen over to deep blue. So now you have full color, red, green, and blue. We do that by putting a filter in front of a monochrome sensor, and so only that light hits the sensor. Okay, that motion was the actual telescope moving. So we can see it jumped. 1 to the next, which is actually fine. I'm not really concerned about that. I would be concerned if the stars started to streak. They're streaking a little. No, well, yeah, slightly. But we're still seeing comma, and we're still seeing an elongated tail. We're seeing that even if you look at this slight streaking of there, this streaking is even more. So it looks like this comet is moving, and let's compare it to the previous one, see how much it moved. It's probably not much. So if I do that, I'm comparing it to that blop right there, if that's a star. That blop, it moved. In that short time, it moved. So it looks like there's a little star there. That star there, right there, and the comet is just above it. We go to the next one. The comet is a lot closer to it. It's right across from it. How's that? I mean, we actually saw a comet move in just a couple of minutes. That's pretty cool. Curtis, am I thinking of the snow line? I can't remember what it's called. It may be the snow line. I don't remember off the top of my head. I know what it is. I don't remember what the terminology is for it. So, any other questions, comments, concerns? I don't see anyone else on anyone else talking on Zoom. It's all quiet. You guys are seeing the screen on Zoom. That's why there's that green border around it. So we're gonna wait a little bit longer, see what it does next. But that's pretty cool. I expected that we would see a little bit of motion. I just didn't realize it would be that much that quick. But yeah, we are actually seeing a comet move. So if we were going to take a picture of the comet where we want the comet's nucleus to stay in the same position, we would have to use PhD to say, we take a couple of frames and say, okay, here's the comet, here's where it's moving to, and now PhD will track the comet instead of the stars. So maybe we'll be able to do that. We got plenty of time. What we would want to do is I need to swap out for another camera because that one apparently isn't working. Let's see. I'm just getting noise out of it. There's nothing there. So while that thing's going, I'm going to stop PhD. I'm just worried about stopping this right now because, well, it's USB. All sorts of weird stuff can happen to it. I have a lot of bugs flying around me now because I've got lights and they're coming to the monitor, they're coming to my little studio light, and they're coming to me. I had something land on my head not too long ago. Okay, what do you recommend for free and unpaid iOS app? Yes, Sky Safari, there is a free version. There is a paid version as well. I use the pro version on my phone because it's really nice, especially if we're doing, well, I was gonna say if we're doing public star parties. We're not doing public star parties, not at least for a while. Okay, we have a little bit of streaking, but it's now directly over when we were just a little bit above. So let's go back one. So it's a little bit, let's compare it from 2 images ago. Okay, so we can see here's the star. There's something there. There's a star. It's just very, very faint. There's a star right there, and the comet is up and a little bit to the right. I don't know. Can you guys see that? Let me zoom in even more. Okay, so that's the star right there, and the comet is up a little bit to the right. I'm going to go to the latest. Now the comet is directly across from that same star. There's a little bit of streaking, but it's definitely right across there. Cool. Thank you, Bob. I'm pretty stoked about this too. Not every day you can step out in the backyard and see a nice little bright comet. Okay, so Sky Safari. Sky Safari is from Simulation Curriculum. It is the same company that actually makes Starry Night Pro. Starry Night. I think there's like a free version. I know there's like an educational version of it. Oops. So this is what the program has. I can tell you right now, tail does not look like that. But this is the generic version that it's got. I don't know where. I just don't know what star. No, I think that's too far away. I think this is a bright star somewhere off to the side. I'm not really concerned. This is what I want to see. This is this is what I'm more interested in right now, instead of knowing what all these little stars are. So on the PC, whether it's a PC or Mac, I would go with Starry Night Pro. There's also additional software. There's the SkyX. That's really meant more for a professional level or a very dedicated amateur. It integrates with high-end mounts like the Paramount series. Software Bisque is the company that makes both the SkyX and the Paramount stuff. They're very, very good mounts. They're very, very expensive mounts. But Simulation Curriculum is the company that makes Starry Night, and it makes Sky Safari. So Starry Night is the PC and Mac application, and then for portable devices, for phones and tablets, it is Sky Safari. Both are very good. The difference in the levels is going to be how many objects you have and what you can do with it. But for most home users, the home version is going to be fine. For astronomers, for people who want to do astrophotography and they really want a lot of control over their devices, they really want to see some of the deeper stuff, they want to be able to find it fairly easily, then we upgrade to the Pro level. I think I've been using Starry Night. It's probably been, I think it's been like 18 or probably 20 years before. I think I actually had it before Simulation Curriculum bought the previous company out or renamed itself or something. But I've had it for a while. All right, so next image. So we're looking at the star right here. Looking at that star. Where is the comet? It should be past and down. Past and down, past and down. Yep, there he goes. There's a star. It's past it and down. So now we've seen it. Let's go back 4 images. Going back 4 images. Here's the star. Comet is up and to the right. Looking again. It is now down, or to the right, and then down a little bit. So just over the course of, what, half an hour or so, we've seen significant motion, visible motion in a comet. So this is going across the sky pretty quickly. It is far. I'm not really sure how far. Let's find out. Neat thing about this is I can click on it. It'll tell me general info, blah, 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 position, tells me about it. That's the general stuff. Azimuth, attitude, and position in space. Here we go. So we can see it is getting closer to us. It has not reached its closest point to us. It is going closer to the sun still, and distance from Earth. So this is center of the Earth. This is to where we are here in Dallas, Fort Worth. And it's doing its thing. Now, we have a lot of comets that are actually found too late, I should say. We have several sun-observing satellites that their whole job is to look at the sun. There are several that look, or there's one that looks directly at the corona, and that one picks up a lot of comets as they come in and fall into the sun, and we miss them. They're coming in from the other side of the sun, and they come in very quickly. Some of them, they're called sun grazers, that they come in very, very close to the sun, and usually they either break up completely or they break up into pieces, and then when they come out, they're now, separated out. There are multiple comets instead of just one, and others just fall right in, and we never even notice, except for a couple of images off of sun-observing satellites. Let's go back. If you're just joining us, we are looking at Comet ATLAS C 2019 Y4. We're taking a number of exposures so that we can see the actual proper movement of the comet through space. We're seeing the nucleus right here. We're seeing a bit of a comma, and we see definite elongation of a tail. If I were at one of our dark sky sites and I had the guider all set up and working, I would be taking some longer images. I'd be tracking directly on the comet. I think this is neat. What do y'all think? I haven't done this in a while, so to me this is fun. This is interesting. I always enjoy doing star parties. I enjoy showing stuff like this to the public. It's not every day that you get to show off a comet. Usually we show things like, well, the moon. Speaking of the moon, I see it poking out from behind my house now. It's getting a bit lower in the sky. I see Venus there as well, and it's a little bit hard to make out. I have no... Venus is right above the treetop there. Oh, there's the Pleiades. I see the Pleiades right now. I'm sorry, I have no night vision now whatsoever. I have the monitors. I have monitor. I have the laptop. I have a studio light shining directly in my eyes. I see Sirius, the moon, Venus, and that's... I can barely make out Polaris, and I think Big Dipper should be there somewhere over my right shoulder. Okay. We got more elongation, but we got elongated stars, and I stopped taking images. Okay, so we're seeing elongation. I'm going to try to swap out for a different camera. And I'm Chris Modnitsky. I'm the president of the Fort Worth Astronomical Society. We are doing a virtual star party because COVID-19 has us locked down, and it is dangerous to have large groups of people together. We recently found out that, or it appears that COVID-19 can be spread simply from breathing, not just from coughing. So just by being around an area where someone is who is infected, who's breathing in and out, can be dangerous. So I'm going to go back to, let's see, to here. We can look at the comet. I'm going to go back to a slightly better image. People just joining us. If anyone has any questions, go ahead and type them out. As soon as I get back from installing this thing, we'll see if we can get it working, and I'll try to answer them. The way I intended. That wasn't good. Oh. Well. Alright, well, I dropped the camera, but, well, ZWO makes really nice cameras. They're solid milled aluminum bodies. I just scratched up a little bit, one piece of it. That's fine. Okay. Let's see if we can do this again. So I'm going to bring in push here dummy. Okay, so this is the application that we use for guiding. It's called Push Here Dummy. I'm going to reconnect to equipment, disconnect. What is that? Select which camera. Okay. Connect. That's fine. Mount. Connect that. Close that. All right. Start 2-second exposure. 1, 2. I'm hoping this is because there's nothing in focus. I'm hoping that's what it is, but I'm not 100% positive. All right, so there's a whole bunch of stuff that, well, yeah, this isn't working quite the way that it had been before. I think it's because it's totally out of focus. I'm going to jump over and see if we can get this in focus. We need a little bit of guiding to make this image good. What are we looking at? We're looking at... Need to be able to find a star. I haven't been able to find a star. Sorry, I got a headlight here. Don't see any stars. Just out of curiosity. Okay. Alright, the camera is actually working. That's good. But I'm not picking up any stars. So here's what we're going to do. I'm going to set this as a longer exposure. We can just call this technical difficulties, right? I'm going to do a 3-second exposure. Come and see if I can see any stars showing up. So what this does is takes a picture for 3 seconds, and takes another picture for 3 seconds. I'm still not seeing anything. I should be able to see something. I can't see anything. So you know what? Here's what we're gonna do. We're gonna go to the Comet. We're gonna come back. Because what I'm going to do right now is move this over. We're gonna go back to here. Actually, no, we're gonna do this. We're gonna go back to here. So we're still locked on the Comet. I can see the moon. This is literally what we do. We find something we can actually see. I go back to the moon. I'm going to slew to the moon. And I hope that this is going to work. We're going to go to planetary again. I'm listening for... There we go. Okay, cool. So we got the moon. Let's see how noisy this is. Ooh. Yeah. So we can see the moon, but it is just... No, thank you. Okay. So I am... Alright. So here's what I'm looking at with this image. So this is my auto guider camera. Let's swing this over. That is pretty out of focus, isn't it? So here's what I'm going to do. I'm going to go over there and try to get it into focus. That is still not in focus, is it? That is actually horrible, isn't it? Okay. Need a solution. Find one real fast. The solution has got to be something about right here. This is my solution. A diagonal. I need more length on my focal distance. Diagonal is going to do it. Like I said, it's not pretty, but it'll work. Hey. Shoving this in diagonal. Go. Taking the in. I'll just do an angle too. Okay. Go. Oh, yeah. How is that? That's ugh. I got it right. We seeing any detail there? I think this is as good as it's going to get. Yeah, I think this is probably as good as it's going to get. It ain't pretty, but it's doable. Okay, cool. Now okay. 11:26. We got plenty of time. Okay. Yeah, Kurt, this is typical. This is absolutely typical. Stuff just happens. All right, so I want to take PhD, and we're gonna go back to here. We're gonna go back to Atlas. We're gonna go slew back to Atlas. And you can see that the scope's moving back behind me. Pretty. So back over northwest. Come on, Polaris. Oh yeah, see, it's actually moved even further over just in the course of the night. Back. All right, so we've got this. That's good. PhD. I'm going to take a much longer exposure out of PhD because I just want to see if we can pick up anything anything with a comet. I don't see anything yet. Oh, there it is. Hey, cool. We got the comet right there in PhD. That's not bad. It's not bad at all. This is a what is that thing? Oh, this is a 70 millimeter Celestron short tube. I think it's like an f4.5 or an f5. It's a this is like on their this is like a really cheap travel scope that Celestron has, and I actually bought this one off of Cloudy Nights for super cheap. I think it was like $20, and I'm using this as my guide scope. So I have it mounted on top of the 8-inch. I've got a guide camera on there, and let's be honest, the guide camera is a lot more expensive than the telescope is. But at 60 millimeters, this is enough that I can actually see the comet. So I wish this thing could zoom in a little bit more, but it can't. So instead, I'm just going to do a 5-second exposure. So what I'm doing is it's taking 5-second picture, and it seems, there we go. It's coming out a lot better now. So I'm going to click on this and see what it can see. So it's got something. It's not exactly certain what it is. What I can do is I'm going to grab this. I've got a star right there, and I'm going to hit. Is it going to train it? I'm going to guide. Okay. I'm going to see if it's going to guide first. I may need to do something else. I'm doing a 5-second exposure. We don't want to do it too fast. So typically the least I do is about 1 second for corrections. I don't want to do any more because or do it any faster, because sometimes it's called chasing seeing. So what happens is just atmospheric variations, just air moving causes the images to, well, twinkle. That's why stars do twinkle. So if it twinkles in this direction, twinkles in that direction, I don't want the scope constantly chasing that seeing. I want it to try to stay on there as best as possible. So what this is doing right now, this is doing some transforms on there and running calculations just to see is that star in sharp focus. It's not. I don't really care that much. It's fine. It's good enough. It's for what I want to do. But yeah, we actually have a comet right there in the field of view. All right, so I'm doing 5 seconds. I don't think it's actually guiding. I'm not seeing, yeah, it's not actually guiding. So what I need to do is tell it, oh, let's see, modify calibration. I need to clear calibration data. Now we're going to teach it what to do, or it's going to teach itself. I'm going to pick a decent sized star. I'm going to go ahead and take this down to 1.5 seconds. So I want it to loop. I want it to take a picture of the star. A little bit more. No, better. There. And I'm going to say start guiding. So here's what it's doing. It's locking in the star, and then it will move it in one direction, saying west, step 3, down here at the bottom. So it's moving it in one direction, and then it will move it in another direction. It'll go west. What do you mean star lost? It's right there. I wonder if it needs longer exposure. I think it needs a bit longer of an exposure. Step 5. Yeah. How about stop? We'll do a 3-second exposure. Loop again. I guess I could guide it on that bright guy too. I think he's too bright. Let's try this again. I can honestly say there have, I think I wasted 2 years trying to get my auto guiding working with one mount, and then with this one. And finally, I had an aha moment, said Eureka, and figured out what I was doing wrong. Finally got it working. And now it just seems to work. So it was all about getting the settings right, and I had people helping me, and didn't matter. It was until I figured out what it needed to be for my own equipment. And now that I have figured out, I can actually do it on someone else's equipment as well. I can calculate the settings and do it for somebody else. So it's still testing. I really hope this is going to work. I like to get some decent guiding. So it's doing west. It should then move to the east. And you can see it's not perfect going to the right. It doesn't matter. It figures it out for itself. West step 12. Come on. Come on. I think the settings are different than what they were last time. I don't think I saved the changes that I made. Well, this part is kind of dull while we wait. Anyone have any questions? I can see that we only have 4 people in the Zoom chat. But everything else seems to be going okay. It is kind of quiet. It's a quiet night. Oh man. Step 19. I don't know how well this is going to work, so let's let it do its thing. Go back to the Comet so you can see it's moved off. I'm going to do something. Well, I don't know if this is going to mess us up. It should not. Well, I don't know. I don't want to mess this up right now, especially while we're doing the guiding. But what I want to do is lock on the Comet, go back in time. I guess we are locked. We're at least centered on it. Well, actually, y'all take a look. So it's barely moving. Let me zoom in more. Well, no, the whole thing's moving. I want to select just that. It's not letting me select the Comet now. Nope, it's not letting me select it. That's okay. Let's go back to PhD. Star lost. How could I lose a star? It's right there. I don't know. Okay. Mike. Yeah, sometimes it is cheaper. Here's what I would do. I would look at not just the AVX, I would be looking at other mounts. You can get a CGEM DX, which will handle 40 pounds as its max payload. Ideally, it's max payload. I've actually loaded it up with more. And I got mine as a big package deal, but I've seen them for about $1,000. And that's really good for the mount. When it was new, it was about $2,000. So what you can do is get one for about $1,000, and then you can hyper tune it. I've done that with mine. There is a hyper tuning kit. Just look up Hypertune CGEM DX. There's a company out there that does it. I can't remember what it is off the top of my head. If someone can remember and put that into the chat, that'd be great. And what you do is you polish off the insides. You make a whole lot of swaps of various materials. You put in Teflon pads. You replace some bearings. Oh, mine definitely needed bearings replaced, but you get a much smoother mount out of it. A lot smoother than it came from the factory. So those are always options that you can do. So for anyone joining us now, again, my name is Chris Młodnicki. I am the president of the Fort Worth Astronomical Society. We're doing a virtual star party because we are in lockdown and we can't have a one of our normal star parties out at Tandy Hills or at Dinosaur Valley. So we are doing this instead. So the Fort Worth Astronomical Society, got a question about a little bit about FWAS. Okay, so we've been around for just over 70 years. Our founder was Charlie Mary Noble, and the Noble Planetarium at the Fort Worth Museum of Science and History is named for her. We have 2 dark sky sites. We have one north of Decatur. We have one north of Ranger. They are pretty dark. The one in Decatur actually has a really nice bathroom, and it has power. The one out north of Ranger actually has darker skies, but it has a composting toilet, and you have to pretty much bring your own power. I'm going to go ahead and kick off another imaging session, so we're going to do 2 minutes and see what that's like. What else do? We do, well, the star parties are a big chunk of it. We have club meetings once a month. However, those have been canceled. For March, I did a virtual club meeting. Again, it was a YouTube broadcast. I will do another one in April. This one will have the Zoom session set up, so hopefully we'll have a little bit more interaction, except for, well, other than me just sitting in my dining room and talking, kind of like what I'm doing right now, except I'm outside. What else do? We do a lot of outreach events. It's not just star parties. We do things like the Fort Worth Museum of Science and History. We've had several events there. For the Apollo 50th anniversary, we had events at libraries in Irving and Crowley. We also were at the University of Texas at Arlington Planetarium, helping out there. At the Fort Worth Museum of Science and History, we'll bring out the meteorites. So I have a fairly extensive collection of meteorites, and we will take them out to events. So instead of just seeing a meteorite behind a piece of glass and reading off a little label, oh, this landed here in this year, instead I just let you hold them. If you've never held a space rock, it's something really, really cool that you can do. So we'll have regular meteorites that you can hold, and I actually have a moon rock that you can hold. It's really small. It's 2 grams, it's about 2 centimeters across, but it's an actual piece of the moon. If you want to, you can look up Northwest Africa 11421, NWA 11421, and you can actually read about where it landed, who found it. I know the 2 guys who had it analyzed and who have the main masses. And they're really, really good guys. And they are meteorite hunters. I have not found any of my own. I have just got them from various dealers around the world. I have one which is really neat. It's called Northwest Africa 10331. There are 4 pieces of this rock. I have one. My dealer up in Canada has one. A collector friend of his has one. And the last one, it is owned by Tomasz Jakubowski in Poland, but he has given it to a Polish grad student to use on his PhD thesis on early solar system origins. Because this particular rock is primordial. It is 4.5 billion years old. It is older than any rock on Earth. It contains material from the original formation of the solar system. So it's something very, very interesting, and interesting scientifically, that I take out to events so people can actually see this rock, this slice of a rock, is older than anything on Earth. It's older than anything you'll ever touch, probably. It's older than moon rocks. And there are only 4 pieces of it too. So when a rock is cut open and it's found to be kind of interesting, there are several university labs around the world where you can actually send your rock and a sizable chunk of money, $150, something like that. It depends on the lab, but they'll go ahead and analyze it and tell you what it's composed of, and if it is a meteorite, they'll give you a classification. Back in January, I did a talk on meteorites for the club, and one of the things I had on there was meteorongs, and they're rocks that look like meteorites but aren't. And I actually have several that I take out to outreach events because it's a good way to teach kids what is a meteorite and what isn't. So we're ready to download. What do we got? What do we got? What do we got? We got noise. That's what we got. We got some serious noise here. I don't even know what's going on. Did I just take a bad image? That's just really noisy. Wonder what happened. Oh, 52 degrees. There we go. We're at 52 degrees. That would do it. So we're seeing a lot of noise because it's a hot camera. Okay, so we significantly went up in temperature. We were, I think, like 29 degrees, and we went all the way up to 52. So, got one right there. The next one is quite a bit noisier. Oh yeah, that's pretty noisy. This is something that this is a killer. So this really destroys images, having very, very hot chips. And this is the temperature on the chip. So we want it as low as possible so we minimize the amount of noise. We're just, that's what we got. So let's see if the next one, if it's any cooler. If not, we'll have to do something else. I'll stand over there and blow on it really hard for a while. How's that? So I have a question from Teddy Texas 1. What do you recommend for newbies? Does your website have lessons on how to begin in one's own backyard during this time of social distancing? And Mike asks if I have doing a Peltier cooling unit on the chip. Yes, I have one. No, I'm not using it tonight. But yeah, I do have one. It's in my office. I need to put it back together again and hook it up, especially because we're going into the summer. During the winter, it's not really that big of a deal, but in the summer, yeah. I've actually had my chip up to like 60 degrees, and it sucks. So we want it as low as possible. All right, back to newbie recommendations. Recommendation is always, always, always get a pair of binoculars. Don't go to Walmart. Don't go to Amazon and pick up a $100 telescope. The guide scope that I'm using right now, this is a $100 telescope. I bought it for 20 bucks. It is not a very good telescope. The images are going to be not very sharp. The focuser is going to have a lot of slack to it. It's going to move around. There's going to be a lot of color on very bright objects. If you're looking at the moon, you're going to see a yellow and purple halo around it. If you're looking at Venus or any of the planets, you're going to get the same thing. And you're not going to be able to see all the pretty pictures that you see on the side of the box. If you look at the Orion Nebula, it's not going to be that pretty. It's going to look like a gray little cloud. Well, guess what? Through these telescopes, if I just put an eyepiece there, it's going to look like a gray little cloud. Instead, get a pair of binoculars. See if you want to do it. Get a good pair of binoculars, because a good pair of binoculars will last you a long time. I've got a pair of Nikon 10x50s that are now 20-something years old, and I still use them. Not every time I go out, but probably every 3 or 4 times I go out. Especially if I'm going out to dark sky side, I have them with me, because you can see stuff in there and pick stuff out much more easily and faster than you can with the telescope. If you decide you want a telescope, you're definitely interested, you've caught the bug, I would go with a Dobsonian. I would look at either an 8-inch or a 10-inch Dobsonian to start off with. The reason why I say that is an 8-inch to 10-inch will last you a lifetime. If you go with like a 4.5-inch or even a 6-inch Dob, you will get a horrible, horrible disease we all get called aperture fever. That is a horrible disease that makes you hemorrhage money. I mean, you look at your pocketbook one day and you look at it a second day, there's a lot less in there. New image, a lot less noisy because we've dropped down to 38 degrees Celsius instead of 52. Let's zoom in, see what we got. Stars around, and it's moved. Where? Let's go back. I want to go back to a previous image. So we're looking at these three stars, and we have a star right there. These three stars, and that star right there, and now we're well below it. In the course of a night, in less than 2 hours, what was it, an hour and a half? Hour and a half-ish? We've moved from over, where was it, over here? Over here? Something about there. Down to here. Let's take a quick look of where we were compared to where we are. 1, 2, 3. Can't really make that out. Let's go to the next one. Let's go to that one. 1, 2, 3, and something. So let's look at these stars. 1, 2, 3, over and up. And now, one, two, three, and down. We were here, now we're here. Over the course of an hour and a half, we've actually seen this comet move. That's pretty cool. Let's see. I don't see any other questions going through. Okay, so we're still imaging. We're still taking more images, which is absolutely fine. Probably still take even more. What was I going to say? Oh, telescope. So 8-inch Dob to 10-inch Dob. And your limit should be how much are you going to carry and can you put it in your car? How much can you carry? That's really important because a really big telescope is absolutely fantastic. But if it weighs 100 pounds, are you really going to drag it out every clear night? Are you going to look at it and go, I'm kind of tired tonight. I don't feel like dragging it out. I had a 16-inch tube Dob. The tube alone, not counting to the base, was 90 pounds. The base was like another 60 or 70 pounds. I rarely took it out. It was so heavy that it was one of those, yeah, I can, but I don't really feel like it. I have two 8-inch Dobs. Those are truss Dobs. They're much smaller, they're much lighter. It takes 5 minutes to set up. I don't have issues setting those up. If it's a decent night and I want to do some observing, I will take it out. Those things over there, I think the tripod weighs about 35 to 40 pounds. I think about 40 pounds. The mount is another 30, the mount on top is another 30 pounds. To set up all the scopes, all the equipment, run all the cables, test everything, usually takes me an hour on initial setup, and then it usually takes me another hour or so to get everything plugged in and do the troubleshooting and get everything aligned before I'm actually able to do anything. So from start to finish, I always budget about 2 hours. So the question becomes, do I want to spend 2 hours to drag my stuff out, set it up, take some pictures, and then it's midnight and I'm exhausted and I gotta go to work the next day, and I'm not gonna put it up? I actually have a big, I guess you call it a sack. It is I think it's called like a 360 telescope cover, 365 telescope cover. It is waterproof. I can leave it out in the rain. Probably still not a good idea. But I've left my telescope out for a week when we had good weather so that I could have it set up once, and then I can come back, and it only took like 15 to 20 minutes to get it set up and reconnected and tested before I could start imaging again. The less time you spend working and getting your gear up and running, the more time you spend actually using it. This is why I recommend 8 to 10-inch Dobs, especially for people who are just starting off. What you want is something that you use. You don't want something that sits in the closet. The cheap scopes sit in the closet because when you use them, you get disappointed and you don't want to use them anymore. If Jupiter doesn't look good, if Saturn, if you can barely make out the rings and you can't see anything else, if you can't make out banding on Jupiter, if the moon looks purple and yellow, you get disappointed, it goes in the closet, now you've wasted $100. Instead, get a pair of binoculars, make sure you want to be doing this for a while, get an 8 to 10 inch Dob, whatever you can lift, whatever you're comfortable with, and whatever fits in your car for when you want to take it to someplace like Dinosaur Valley where it's really dark, or if you join the club, take it out to one of our dark sky sites. Now, at our dark sky sites, I will say this, we do have telescopes out there already. If you are a member of the club, and once this is all over, we're returning to the dark sky sites. If you're a member of the club, you can go out to the sites, you can use the Dobsonians that are already there. You don't have to have your own. This is a big advantage. Sometimes I don't want to drag all my stuff out there. I will take this stuff because I want to do imaging, but I don't necessarily want to take my Dob along too when I can just pull out one of the ones that are over there. We also have a couple of library scopes. We were given a donation of a Celestron 11-inch CPC 1100. It had some issues, and one of our club members repaired it. It is now in the hands of Patrick. I don't know if Patrick is still on, but Patrick is our outreach coordinator, and he has it because he uses it the most. He takes it out to star parties. He took it out to star parties. He took it out to various outreach events and used it. So, but if one of our club members wants to use it, we just have to get them checked out on it, make sure they know how to use it, and then have it back before the next outreach event. We also have a hydrogen alpha telescope. It is a little Lunt 60 with a mount, with a motorized tracking mount. Again, it is a club telescope. You can check it out and you can use it yourself. Just have it back before the next outreach event. I am actually considering going and taking the hydrogen alpha from Patrick temporarily and having a solar viewing event during the day if it's not cloudy like it was today, but have a clear day and perhaps over lunch or something, because I am working from home, or on a Saturday or Sunday, have a little sun observing event, have the telescope set up, and we can look at prominences on the sun, we can look at flares if anything's going on, we can look at some surface detail that we can't see in white light very well. One of the advantages with that little telescope is hooking up a camera to it, a little black and white, little monochrome camera. We can see a lot more detail than we otherwise would. Our eyes aren't very adapted to seeing deep red light, so instead we see it in black and white, and it's, ooh, hey, did you see that? Did you see that? Did you see that? I saw that. Let's go back to this one. We go up. We go down. Up. And again, a little bit down. Over 4 minutes, that is the motion of the comet. Is that sweet or what? 4 minutes and we have that motion. So again, we're doing a 2-minute exposure and then a 2-minute noise reduction so we can see some of this. And our temperatures drop down to 31 degrees Celsius, which is really, really good. So it was so high because apparently we were doing planetary. And when you do planetary, it's video and the chip warms up a whole lot more. If we're taking images like this, we can keep the chip a lot cooler. Cool. Yeah, Mike, he said a really cool moment where you can see the Cassini division. Yeah, that's always the first time you see something like that is just really cool. I've actually had people at star parties who they did not believe that they were actually looking at Saturn or Venus. So, like through the eyepiece, so one of the neat things is while they're looking, just tap the side of the telescope, and it makes it shake. So it's like you're actually seeing something. It's not like a little. I don't have something taped to the end of the telescope that you're looking at. You're actually looking at the actual object. Um, Now, with a larger telescope, with an 8-inch Dob or 10-inch Dob, you can easily see Uranus has a disk. You can see Neptune has a disk. Uranus is kind of a pale greenish blue. Neptune is definitely a blue color, and it doesn't look like any of the stars around it. The stars are twinkling, but each of those are actually disks. It's something really neat. So yeah, we've got 2 minutes officially left. It's a Saturday night. We're not going anywhere. I don't mind staying a little bit longer if anyone else is interested in staying. We can keep taking more images of the comet, or we can go. I guess we could go look at something else. It's kind of hard to pick out an object. We are in the middle of the suburbs, so it's kind of limited in what we can see. We do have a lot of light pollution. Last time we got to see M48, which is an open star cluster. I really, really, really wish that my other camera was working right. It doesn't seem to be. Let's see if I can reconnect to it. Not letting me connect, so I will close this off, try to restart it. I will say this though, if you have a laptop, if you're getting a laptop to do stuff like this, I highly, highly recommend getting a laptop that's got a light up keyboard. Mine is only lighting up in white. I know that some of the gaming keyboards light up in red. There are even a couple that have full RGB light up keys, which are pretty cool. But this one is nice because you can hit a button and it lights up and I can actually see what I'm typing. So 90 more seconds for noise reduction. I'm pretty happy. I'm pretty happy. We are managing to actually see. All right, my guiding sucks tonight. Yeah, it just not good. But it's fine. It's good enough. It's good enough that we can see a comet. It's good enough that we're able to see that the comet is moving. We're able to see the comet has a bit of a tail. We can make something out. So for that, I'm actually pretty happy. Any other targets? Let's see. John says Chuck was showing solar and it was flat. Yeah, that's the problem. Right now, I think we're close to solar minimum. We're somewhere about there. So I know that I was checking a couple days ago, or no, it was last week, I guess, and there wasn't really anything interesting on the sun at all. There's just no sunspots visible. So yeah, if there are no sunspots, there's not really a whole lot of activity. There may be something on the limb if you're looking in hydrogen alpha, but if you're looking at white light, you're not really going to be seeing anything. Jupiter's moons cast their shadow on the cloud tops. Yes, that is always fun to see. It is an eclipse, usually of Io or Europa. Rarely do you get to see Ganymede or Callisto, but I think it happens every once in a while. But yeah, Io happens rather often. It's always neat to see. I've been up for a while. Our 4-year-old decided that he was going to wake us up at 6:30 this morning. I don't know about y'all, but 6:30 on a weekend shouldn't exist. Because when he was going to school, he would be not wanting to get up until 7 o'clock. But as soon as the weekend comes by, oh no, 5:30 even some days. So it's been a long day. Okay, so we still have motion. Let's check out how much difference there is. Yep, it's a little bit. So for 4 minutes, we see that much difference, and we can actually make out tail is going that way. So I'm gonna see if I can just get this thing down. I wish this thing was better about the histogram, but it's not. Yeah, it's not really that great of a histogram. I am doing this in black and white, so it is a little bit easier to see. If I switch it to color, oh, that's not what I want. If I switch to RGB, then you can kind of see it somewhat, but just luminosity, just black and white, I think it shows up a little bit better. Hello. Here we go. So I think that's fine. Oh, Mike, you just lost all your images. I'm terribly sorry. I highly recommend network attached storage, RAID 5 or RAID 10. I have lost machines before, and I back up all my stuff to a NAS. I lost one NAS, but I knew it was going out, and I moved all my stuff onto another drive. Got new NAS, nice new big drives, moved my stuff right back on. So upgrade every couple years, but I still have a lot of old images, a lot of family pictures. So that's how you keep it. Keep everything keep everything local, back it up to the NAS. Keep it local, back it up to the NAS. Save early, save often. That's a mantra that I've been using for 20-something years. Because I once spent 6 hours working in Photoshop, and my computer crashed, and I lost it all because I forgot to save. Oops, I had to go back and rebuild everything. That was a bad day. But it's alright. Save early, save often now. Okay, any other questions? Is everyone else wanting to head out? Down to 23 concurrent viewers right now. Just 3 of us on Zoom. If you scroll up, you'll find the link to Zoom if you scroll up in the chat. And if you want to connect, I'll go ahead and bring you in. The Zoom session is pretty much just the window that you're seeing right now. That's really it. So, but it's closer in real time. There's much less of a delay. With YouTube, I think there's like a 15 to 20 second difference. Ooh, we're down 28 degrees. Cool. At least not 52. That was one pretty noisy image. Okay, how much has it moved? How much has it moved? Do we see it? Maybe I didn't pay attention. Maybe it was so subtle I didn't see it. Yep. There we go. Very subtle, but the motion is there. So we're able to see it pretty well. Comet's coming out. If I extend the exposure, I think we're going to get more detail out of it, but I'm also worried we're going to get more streaking out of the stars, and we're going to see a lot more light pollution coming in. So we have some diminishing returns out of it. But it's 11:07. If we're getting it's getting late. Oh, and ooh, nice chilly wind is picked up. So I think this is probably going to be a good place to stop. We've been on here about 2 hours now, a little bit over 2 hours. We got to see the moon at the beginning, a little bit of Venus, the Pleiades, and now we spent some time looking at Comet ATLAS C 2019 Y4. And again, I'm Chris Mornitsky. I'm the president of the Fort Worth Astronomical Society. I am tired, and I'm going to let a couple more exposures finish off, and I will process this tomorrow, and I'm going to go home to a nice warm bed. So thank you very much for joining us tonight. Have a good night, and stay safe.